In this video, we'll be talking about finding the area under a line or a curve. Suppose you're given something like a line here. Let's call this f of x. And you're given the points or the limits of, let's say, point A and point B. This is the area to which you would want to find the area of, not including this or this, because it is bounded by 2 points. And so, the formula for this would be area would be equal to the integral of f of x. And since our given limit here is at the point of x-axis, we call this dx. And the upper limit here would be point B, and the lower limit would be point A. Suppose you are given here another curve with the limit point of, let's call this point C and point D. So this is the area to which you would want to find. Let's call this curve now g of y. The formula for this would be area would be equal to the integral of g of y dy, with the upper limit of d and the lower limit of c. So this would be the two formulas to which we would use. Let's start with this first example. Find the area bounded by the line y equal x and x equal 0 to x equal 4, and also bounded by the x-axis. So what we're going to do here first is to plot and graph first. If you don't know how to graph something like this, just use x and y table method. Substitute random values for x in order to get the values of y. So let's say if x here is equal to 0, y here would be also equal to 0. If x is 1, y also would be 1. And let's go on until x here would be equal to 4. So if x is 2, y also here would be 2, and so on. So these are the points to which we can plot the graph here. X would be 0, y 0, 1, 1, 2, 2, and so on. So this is a linear equation. Good enough. And so our limit here would be equal to x equals 0. So it's around here. And x equal 4. This would be x equal 4. So the area would be this one. And so, let us solve this. Area right here would be equal to the integral of f of x dx with the upper limit of b and lower limit of a. Keep in mind that f of x is equal to y. And since y here is equal to x, so this would be x dx. B here is 4 and a here is 0. Anyway, note that the upper limit here is what the bigger number here is, and the lower limit is obviously the lower number. And so, the integral of x dx would be equal to x squared over 2. And so we'll substitute 4 first in the x. So this would be 4 squared over 2. And subtract this by putting value of 0 into the x. So this would be 0 squared over 2. This would equal to 0. So what we're left with here is 4 squared would be 16 over 2. 16 divided by 2 would be 8 square units. So this is the total area of this shaded region. Let us move on to the next example. Find the area bounded by the curve y equal 4x minus x squared, the x-axis, and x equals 0 to x equal 4. So, first let us plot and graph the curve first in order to visualize what is going on. Our curve here is y equal 4x minus x squared. So, using the x and y table, if you substitute 0 amongst this x, 4 multiplied by 0 minus 0 squared, this would equal to 0. So y here would be equal to 0. If you substitute here is 1, y here would be equal to 3. If x here would be equal to 2, 4 times 2 would be 8 minus 2 times 2 would be 4. So this would be equal to 4. If x here would be equal to 3, y here would be also equal to 3. X would be equal to 4. Y here would be equal to 0. And we can stop here because our upper limit is x equal 4. Now that we have our point, let us graph this. So this would be 0, 0, 1, 3, 2, 4, 3, 3, and 4, 0. If you want to visualize how the graph will go, let's test if x here would be equal to negative 1, y here would be equal to negative 5, and if x here would be equal to 5, y here would be equal to negative 5. So, you can see here that it will go down, it will never go back up now. And so, this is the area to which we would find. And so, our area right here would be equal to the integral of the value of y, which is 4x minus x squared of dx. And our upper limit here, if given, it is just simple, which is 4, and lower limit would be 0. But if you also look at the graph, the point here is at x equal 4, and the other point here is x equal 0. So, integral of 4x would be 4x squared over 2 minus the integral of x squared is x cubed over 3. So, let us substitute 4 first into this equation. So, this would be 4 multiplied by 4 squared over 2 minus 4 cubed over 3 minus 4 0 squared over 2 minus 0 cubed over 3 . This would equal to 0. 4 squared is 16. 16 multiplied by 4 is equal to 64 divided by 2, which is 32. Minus 4 times 4 would be equal to 16 multiplied by 4. It is also 64 divide by 3. And so, doing a common denominator, multiply 32 by 3, which is 96, minus 64, all divide by 3. And so our area right here would be equal to 32 over 3 square units. Moving on, find the area bounded by the curve y equals x cubed minus 6x squared plus 8x and the x-axis. Now, this time, we are not given any limits. So, let us first graph it in order to analyze what we're dealing with here. Our curve here is y equals x cubed minus 6x squared plus 8x. Using the x and y table method, if x here is equal to 0, y here would be equal to 0 also. If we substitute 1 amongst all of the x, we would have y equal 3. If x here would be equal to 2, y here would be equal to 0. If x here would be equal to 3, y here would be equal to negative 9. But we are not still stopping. What we're looking for here is something else. If x here is equal to 4, y here would be equal to 0. If x right here would be equal to 5, y right here would be equal to 15. So let us first graph this. When you're using x and y table here, it would be best to like stop until 5 or until if the y is like a big number such as 15. So this would be 0, 0, 1, 3, 2, 0, 3, negative 9. Let's just estimate this as like this. 4, 0, and 5, 15. So it is a very big y value. So it would be something like this. Wait. So something like that. What we're dealing with here is, if we are not given a limit, we can first experiment using putting values of x. But if the y here is a very big number now, such as 15, if we experiment if x here would be equal to 6, let me just calculate this. So, if x here is equal to 6, y here would be equal to 48. So we can conclude that it will just go up and up. It will never go back down to the curve. So we are good here. And so what we have here is two separate areas that is bounded by x-axis. This is the area number 1 and this is area number 2. This point here is equal to this point, which is 3, negative 9. Keep in mind. And so, let's call this area number 1 and this one area number 2. We will find the area one by one for this. And so, area number 1 first. This would be the integral of value of y, which is this. X cubed minus 6x squared plus 8x of dx. Now, our upper limit right here is bounded by this only curve. So, it would be this point, which is x equal to. And the other one is this point right here. which is 0. So our upper and lower limit right here would be equal to 2 and 0. Integrate this one by one. Integral of x cubed would be x to the power of 4 over 4 minus 6x cubed over 3. Integral of 8x would be 8x squared over 2. So what we're left with here is x to the power of 4 over 4 minus 6 divided by 3 would be 2x cubed plus 8 divided by 2 would be 4x squared. And so let us substitute 2 first into this equation. So this would be 2 to the power of 4 over 4 minus 2 multiplied by 2 cubed plus 4 multiplied by 2 squared. And if you substitute 0 amongst all of these x's, you would have an answer of 0. So no need to waste your effort writing it. Two to the power of 4 would be 2 multiplied by 2, which is 4 times 2 would be 8 times 2 would be 16 divided by 4, which is 4. Minus 2 cubed is 8. Multiply this by 2, which would be 16. Plus 2 multiplied by 2 would be 4. Multiplied by 4 would be 16. So this would cancel. And so what you're left with here is area number 1 would be simply 4 square units. And so let us move on to this other area, which is area 2. Area 2 would be equal to the integral of this curve again, which is x cubed minus 6x squared plus 8x of dx, with the upper limit of, since this is the area which we're talking about, this would be the area, which is 4, and this area, which is 2. So this would be upper limit of 4 and lower limit of 2. So integrate this. This would be x to the power of 4 over 4 minus 6x cubed over 3, or this would be 2x cubed plus 8x squared over 2, or 4x squared. And so substitute 4 first into the x equation. So this would be 4 to the power of 4 divided by 4 minus 2 multiplied by 4 cubed plus 4 multiplied by 4 squared. Subtract this by value of 2, which is 2 to the power of 4 over 4 minus 2 multiplied by 2 cubed plus 4 multiplied by 4 squared. So 4 multiplied by 4 would be 16, multiplied by 4 would be 64, multiplied by 4 would be 256 divided by 4, or this would be simply 64. Minus 4 cubed would be 64 multiplied by 2. This would be 128. Minus 4 squared is 16 multiplied by 4 is 64. So as you can see here, wait, this should be plus, So as you can see here, 64 plus 64 would be equal to 128, and subtract this by 128, you would have an answer of 0. So this would all equal to 0. So what we're left with here is this equation. So this would be negative 2 to the power of 4 would be 16 divided by 4 minus 2 cubed would be 8 multiplied by 2 would be 16 plus 2 squared would be 4 multiplied by 4 would be 16. 16, negative 16 plus 16 would be 0. So what we're left with here is area sub 2 would be equal to negative 16 over 4 or negative 4. The negative is understandable here because keep in mind that we are below the x-axis, so it is on the negative side. And so, when adding this to area, our total area right here would be equal to area number 1. This should be a positive area number 1 because we are above the x-axis. And minus, we subtract this because it is below the x-axis, area number 2. And so, total area would be 4 minus negative 4. And so, our total area for these two right here would be equal to 8 square units. Now, let us look onto Now, let us look onto this diagram. What we have here is the curve y equals x squared. It might not be accurate, but it will do the job. So, this is the shaded area right here with bounded by the points of 4 and 1. And so, our formula for this would be equal to the integral of, since our points here is on the y-axis, this would be dy, this would be g of y, with the upper limit of d and lower limit of c. Keep in mind that f of x is equal to y, and so g of y would be equal to the value of x. And so, g of y right here is equal to x, but what we have here is the curve of y equals x squared. So, in order to get x, we must take the square root of both sides. So, x right here would be equal to the square root of y. And d right here is the upper limit, or basically the bigger number, which is 4. And the lower limit is the lower number, which is 1. One thing also to note, if you are doing the correct step, is that if it's in the dy form, your terms here must be also in the y term. If it's in dx, your terms right here would be simply have an x, not y. Anyway, that's just a thing to know if you are doing the correct step. And so, let us, in order to integrate this, it would be better to put it on an exponential form. Integral of y to the power of 1/2 would be y to the power of 3 over 2 over 3 over 2 with the upper limit of 4 and lower limit of 1. So let's just simplify this first. Put 3 over 2 on the top, so this should reciprocate. 2/3 multiplied by y to the power of 3/2. Firstly, substitute 4 into the value of y. So this would be 2/3 multiplied by 4 to the power of 3/2. Subtract this by the value of putting value of 1. So this would be 2/3 multiplied by 1 to the power of 3/2. So if you don't have a calculator, we can do this manually. Let us focus first on 4 to the power of 3/2. We can rewrite this as 4 multiplied by 3 multiplied by 1/2. Because 2 is at the denominator, so it is 1/2. So we can either raise 4 to the power of 3 first, or raise 4 to the power of 1/2. Let's do 4 raised to the power of 3 first, which is 64. And don't forget there is still a 1/2 here. And so if we put this 1/2 into its square root form, this would be square root of 64, which is 8. If we do the other method right here, if we do the 1/2 first, square root of 4 would be equal to 2. And so we will raise this to 3 now. 2 to the power of 3 would be 8. So no matter the order, you will still end up at the same answer. So this would be 2/3 multiplied by 8. 2/3 multiplied by 8 would be equal to 16/3. Subtract this by 1 raised to the power of 3/2 is simply 1. So what you're left with here is simply 2/3. So subtract these two fractions together. This would be 16 minus 2/3. Since they have the common base, no need to do something like multiplying. 16 minus 2 would be equal to 14/3. And so this would be your total square units, or the area of this shaded region. Find the area bounded by the curve of y equals x squared minus 5x plus 6, the x-axis, and x equals 0 to x equal 4. So first, let us plot and graph this first. And so our curve right here is equal to y equal x squared minus 5x plus 6. Let's use our all-reliable method of x and y table. If x here would be equal to 0, this would be 0 and 0, you are left with simply 6. If x here would be equal to 1, the value of y right here would be equal to 2. If x here would be equal to 2, so substitute it. 2 squared is 4 minus 5 multiplied by 2 would be 10 plus 6. So this would equal to 0. If x here would be equal to 3, so this would be 3 squared, which is 9 minus 15 plus 6. It will also be equal to 0. Now, if you encounter something like double 0 of y, we must first, like in order to accurately graph, we must take a number between 2 and 3. Let's just use something like 2.5. So if we put around 2.5 right here on the x, we would have a value of negative 0.25. And so if x here is 3, we would know it's 0. And we would stop at x equal 4 because that is our limit. If x is 4, y here would be equal to 2. And so let us plot this graph. First, so this would be 0 to 6, 1, 2, 2, 0, 2.5, and negative 0.25. Let's just estimate it as like this. 3, 0, and 4, 2. Wait, this should be in here. So let us draw this curve. Oh no, I'm not good at this. So it would be something like this. And so plot our limits, x equal 0. So this would be x equal 0 and x equal 4. So you can see here we have 3 areas now. This would be the first, this would be the second, and the third. So let us call this area 1, area 2, area number 2, which is this area, and area number 3, which is this area. And so let us first solve area number 1, which would be the integral of f of x, which is y, which is this curve right here, x squared minus 5x plus 6 of dx. And our upper limit right here is bounded by this shaded region, which points to this point right here. Wait, if this is the graph, this should be straight onto this point right here. My graph is just not accurate, but bear with it. So this should be point number 2. And our lower limit is 0.0. So this would be upper limit of 2 and lower limit of 0. Integral of x squared would be x cubed over 3. Integral of 5x would be 5x squared over 2. And integral of 6 would be simply 6x. So substitute u. This would be 2 cubed over 3 minus 5, 2 squared over 2 plus 6 multiplied by 2. If you substitute 0 amongst all the x, you would have a value of 0. To the power of 3 would be 8. 2 squared would be 4, multiplied by 5 would be 20, divided by 2, which is 10. Plus 6 multiplied by 2 would be 12. And so, eight divided by 3 minus 10 plus 12. This would all equal to 14 over 3. Wait, let me just check. 8 minus 3 times 10 would be 30, plus 12 times 3 would be 36. So 6 plus 8 would be equal to 14 over 3. Yep, it is, my calculation is correct. And so area sub 1 would be equal to 14 over 3 square units. This area right here is equal to 14 over 3. Now let us move on to area sub 2, or area number 2. We would now focus on this shaded region right here. So this would be the integral of x squared minus 5x plus 6 of dx. And our upper limit right here would be this point right here, which is 3, and this point right here, which is 2. So this would be 3 and 2. Integral of this would be x cubed over 3 minus 5x squared over 2 plus 6x, with the upper limit of 3 and lower limit of 2. So substitute 3 first. This would be 3 cubed over 3 minus 5x, or it is 3 squared over 2 plus 6 multiplied by 3 minus 2 cubed over 3 minus 5 multiplied by 2 squared over 2 plus 6 multiplied by 2. Three cubed would be equal to 3 times 3 would be 9 times 3 would be 27 divided by 3, which is simply 9. Minus 3 squared would be 9, multiplied by 5 would be 45, divided by 2, plus 6 times 3 would be equal to 18. Wait, let's just solve this first in order to simplify now. So, multiply 9 and 18 by 2, which is 18 minus 45 plus 18 times 2 would be 36. All divide by 2. Let me just calculate this. We would have a value of 9 over 2. So this right here is equal to 9 over 2. Minus 2 cubed is 8 over 3. Minus 2 squared would be 4, multiplied by 5 would be 20, divided by 2 would be 10, plus 12. Which this would be equal to 14 over 3. So 9/2 minus 14 over 3. This would be equal to negative 1 over 6. And it is understandable that it is a negative because it is below the x-axis. And so, let us move on to area number 3, which would be this. So this would be the integral of x squared minus 5x plus 6 of dx, with the upper limit of this point right here, which is 4, and this point right here, which is 3. So this would be x cubed over 3 minus 5x squared over 2 plus 6x, with the upper and lower limit of 4 and 3. So substitute 4 first. This would be 4 cubed over 3 minus 5 multiplied by 4 squared over 2 plus 6 multiplied by 4. Subtract this by value of 3, which is 3 cubed over 3 minus 5 multiplied by 3 squared over 2 plus 6 multiplied by 3. Four cubed would be 64 divided by 3 minus 4 squared would be 16 multiplied by 5 would be 80 over 2, or this would be 40, plus 6 multiplied by 4 would be equal to 24. Subtract this by this one. 3 cubed would be 27 divided by 3, or this would be 9, minus 45 over 2 plus 18. Now, I'm not gonna manually solve this. I'm just going to do a calculator. Area sub 3 would be equal 5 over 6. Total all of this. The total area would be equal to a sub 1 minus a sub 2, because it is at the bottom of the x-axis, so it would be minus, plus a sub 3 because it's at the top of x-axis. And so this would be 14 minus 3 minus negative 1, 6 plus 5 over 6. And so this would be equal to 28 plus 1 plus 5 all over 6, which would equal to 34 over 6. And so the total area would be equal to 17 over 3 square units. The last example, find the area of the region bounded by y equals x cubed minus 3x squared plus 2x plus 1, the x-axis, and the vertical lines x equals 0 to x equal 2. So, let us first plot and graph it. So, our curve here is y equals x cubed minus 3x squared plus 2x plus 1. Let's use the x and y table. Since our upper limit is x equal to, we can just like give x a more like decimal value in order to more accurately graph. So if x here is 0, y here would be equal to 1. If x here is something like 0.5, y right here would be equal to 1.375. If x here would be equal to 1, y here would be also equal to 1. If x here would be equal to 1.5, y here would be equal to 0.625. And so if x here would be equal to 2, y right here would be equal to 1. So let us plot this. So this would be 0, 0.5, 1, 0.5, 1.5 and 2. So this would be 0.5, 1, 1.5, and 2. And so x0, y would be 1, 0.5, and y here would be 1.375. Let's just estimate this as something like, something like this. x1 and 1, 1.5 and 0.625. 2 and 1. And so, plot the limits. X equals 0. So this would be x equals 0 and x equal 2. This would be 2. And so let us draw the curve. Something like that. And so this is the shaded region to which we would want to find the area. So this curve here would be equal to this one. And so area right here would be equal to the integral of the curve, which is x cubed minus 3x squared plus 2x plus 1 of dx. Our upper limit here, if it's given, you can simply identify it, which is 2 and 0. But if you also graph it, you can see it. And so integral of x cubed would be x to the power of 4 over 4 minus 3x cubed over 3. Integral of 2x would be 2x squared over 2. Integral of 1 dx would be simply x. Substitute 2 into the x equation. So this would be 2 to the power of 4 over 4 minus 3 and 3 would be cancel each other out. So you're left with x cubed. Plus this would be also cancel. So you're left with x squared, which is 2 squared plus x, which is 2. If you substitute 0 amongst all the x, you would have a value of simply 0. 2 to the power of 4 would be 16. Divide by 4. Minus 2 cubed would be 8. Plus 2 squared would be 4. Plus 2. 16 divided by 4 would be equal to 4. And so 4 minus 8 would be equal to negative 4 plus 4 would be 0. So you're left with simply 2 square units.